See, this is the dual converter, single phase dual converter. It can be applied for industry purpose both types. It can be single phase dual converter or somehow it can be three phase dual converter. As we are playing in the single phase rectifier which can convert AC to DC, that is why this is a dual converter. Simple circuit connection. This is a bridge rectifier, full-wave bridge rectifier. This is another full-wave bridge rectifier. But see, the switching configuration is not similar to each other. This one is this type of switching configuration, and this is the fabrication is the opposite direction. That means we can say two converter, two full-wave bridge converter are connected back to back. Right? Now see. So each actually delivers the two type of operation. Number one, circulating mode of operation. Number two, non-circulating mode of operation. In case of circulating mode of operation, both converter circuit starts operating at the same instant. For non-circulating mode operation, either the converter operates, it is under off state, or this converter operates, it will be under off state. That is why this is called non-circulating mode of operation. Most interesting part is for non-circulating mode of operation, the voltage which will be delivered by the converter 1, that will be given to the output voltage, that is V0. And for the next case, suppose converter 2 operates and this is under off state position, then the voltage output from converter 2 V02 which will deliver V0. That means what? If it starts working, then this is the output voltage, that is positive and negative. Once it starts working, then the output voltage is this one is positive and this one is negative. That means current from converter 1 that will flow up to downward direction across the load, and the current should start flowing to the load that is down to upward direction. Means the current direction is opposite direction. If both starts working at the same time with the same firing angle, then no voltage will appear across load, no current will deliver to the load. This is called circulating mode operation, because due to the presence of the instantaneous voltage difference, current with high magnitude starts flowing in between the two converter circuits, and that is high enough and which can easily damage the switches which is connected in the same leg. To suppress this amount of current, the current limiting reactor should be connected. Right? Because this is an inductor which is having the sole current slope DIDT, that is why it can oppose the flow of the current spike. Right? Now see, I am talking about the first non-circulating mode of operation. So, if this starts working, it's a rectification mode. Once this starts working, it's inversion mode. Now we know the working principle. Forget this part. Then what happened? This is a simple full wave control rectifier which is having a bridge circuit, and the switch of the bridge that should be given in the same manner T1, T2, T3, T4. That means what? When T1 and T2 will be fired for a certain angle, then the current starts flowing to T1, then low and coming back to T2. That means the voltage VO1 that will be immediately reflected to the fuse. So assume the firing angle for the first phase of converter 1, that is alpha 1. So this is a converter circuit. So input side, that is a AC supply. That is why we have taken a sinusoidal wave which represents the input AC, and the converter 1 which operate at the point of alpha 1. This one is the firing angle. Now we all know when the converter starts working and all switches are fired for the same instant, then immediately the supply voltage will be delivered to converter output, and this is the voltage will be delivered to the load, because we assume then this converter 2 is not under working condition. Then what happened? So this is the input voltage, this is the converter output voltage for converter 1. That is why the output voltage after triggering this waveform immediately will be reflected on this. Right? This load is normally preferred, that is DC machine, which is having the coil, which is having the conductor, and which is having the back EMF. That means we can say this is a RL load application. And we all know for the RL load application, the converter starts working for a particular region, but when the inductor starts discharging, then what happens? It will extend it to a certain time, that is given by meter. That means up to next triggering pulse applied to the next means alternation, it will be continued up to this point due to presence of ARL load. So this is the output voltage that should be taken out from the converter 1. Right? And it is a full bridge rectifier because we are using the bridge rectifier. That is why positive half cycle and negative half cycle both will be rectified. That is why same thing can happen, right, for the negative half cycle also, right? Okay? And to complete the total waveform, it should be this one. So this is the output voltage of converter 1. Right? Now think about the converter 1 stops working. Now think converter 2 starts working. And forget the part that is back-to-back connected. Because the switching configuration is placed in the opposite direction. That is why the output voltage, this one is positive and this one is negative. Right? So that is why assume the triggering angle applied to the converter 2, that is alpha 2. I don't know what is the value of alpha 2 with the terms of alpha 1. That will be discussed later. Just এইটুকু বুঝে নিচ্ছি আমি যে আলফা 2 তে আমি ট্রিগার করেছি, that is given over here alpha 2. That means same thing can happen for converter 2 but the triggering angle is not same. That means what? So it starts working at the point of alpha 2 for converter 2, right? So what is the voltage? This is the voltage waveform up to which? Up to next alpha 2 on this part. So still it is under conductance state for converter 2 circuit. So what will be the waveform? That means alpha 2 trigger, immediately the supply voltage from this part to next triggering pulse up to this point will be reflected to the load, right? That means similarly we can draw the part just in this similar way, right? So this is our output voltage for converter 2. Think it very carefully. Just I am going to draw VO2 and considering two triggering angle. Alpha 1 it was for converter 1, alpha 2 it is for converter 2. So this is the output voltage. So same thing can be applicable for the previous and next. That means it will be started from this point, right? And it will be, right, means this point. So that means it will be completed up to this point. So this is the output voltage of converter, right? But as the both converters are connected in back-to-back manner, that means what happened? If converter 1 will deliver VO1, converter 2 must deliver minus VO2. That is why we are just going to form this waveform VO2. Right? That means VO2 means is a mirror image in opposite side of VO1. Sorry, VO2. Just we are going to draw minus VO2. That is a mirror image of VO2. So how we can draw? See, this started from this point. So it will be started from this point. Right? Next, this point to this point. We can similarly follow this point. Next, it just went from this one up to low position. That is up to low position. Right? What happened? Now, same thing here, the same manner means that it will be in the on this side, right? This side. Again, it is up to downward direction. Next, it will be followed by in this manner. Right? So that means this is a replica or mirror image of VO2. Why we are drawing this part? See, actually, under circulating mode of operation, that we should think about the potential difference for any instant. This is called the instantaneous potential difference. It is true. যখন সার্কিটিং মোড অফ অপারেশন হচ্ছে কোনো ভোল্টেজ অ্যাপিয়ার করছে না লোডে, দ্যাট ইজ ট্রু। বাট ওদের মধ্যে যে পোটেনশিয়াল ডিফারেন্স কন্টিনিউয়াসলি হচ্ছে, তার জন্য দুটো কনভার্টারের মাঝখানে যে কারেন্টটা ডেভেলপ হয়, তার জন্য যে পোটেনশিয়াল ডিফারেন্সটা আমি অ্যাজিউম করছি, দ্যাট ইজ ডিফাইন্ড বাই VR. So what is the stands for VR? VR equal to this voltage minus this voltage. VR means this voltage minus this voltage. কেন বলছি? We all know converter 1 operates for the positive voltage, converter 2 operates for the negative voltage. So the circulating current which should be produced by the voltage difference between the converter 1 and converter 2, that is VO1 লিখতে পারি VO1 minus of minus VO2, that is actually give you V1 plus. তাই জন্য আমি এটা ড্র করে লিখেছি। ক্লিয়ার? এটা ড্র করে লিখেছি। কিন্তু যদি আমাকে এটা করতে হতো ডাইরেক্টলি এটাকে দেখে তার অপোজিটটা ভেবে আমাকে অ্যাড করতে হয়, দ্যাট ইজ নেক্সট টু ইম্পসিবল। Visualize were not possible for exam. তাই জন্য আমি এটাকে ড্র করে নেব। নাও করতে হবে আমরা অ্যাকচুয়ালি to produce VR VO1 plus VO2, that means VO1 plus VO2 এই দুটোকে আমি অ্যাড করছি, রাইট? ওয়েভফর্ম কি করে অ্যাড করব? that means that we have started from 0 to this point. কি আছে? this is the shape of the VO1 and this is the shape of the VO2. That means both lies in the same direction. So we can take this part. So we can take this part, right? This one. After that, this is in the from alpha to beta alpha 1 to alpha 2. This is for the positive side and this is in the reverse side, and the area are almost same. That means positive negative cancelled by each other because we are just adding, just add করছি। That is why it will gives you the manner of straight line, right? Next, see, this one is the positive side, add করছি, this one is the positive side, so it should be followed by the same thing, this one, right? Next is, this is in the reverse direction, this is also reverse direction, so we can draw the same manner over here, right? Next, so this is again the cycle will be repeated. This is positive, this is negative, no waveform will be there, so it will be again straight line, and same thing can be happening for the next cycle onwards. So that means what? That means this is for the potential difference or instantaneous potential difference, and due to this voltage, the amount of current which will start between the two converter circuit, and this is mainly termed by circulating current motor.